Good morning, ma'am. My name is Sri Harshita from CSM department. My topic is triple integrals without limits. First, we will discuss about integration definition. Integration is the inverse of derivation. To find an integral, we find the thing that when a derivative is taken, we get the same thing in the integral. The integral of a derivative is the thing in the integral. There are two types of integrals, definite and indefinite. Integrals may be thought of as infinite sum and they tell us the area under a curve. It is the graphical representation of integration. Our topic is triple integrals without limits. Write the given limits on curves. 1. Write the z limits in terms of x and y using 1. Take the y limits in terms of x by putting z equals to 0 in 1. Take the x limits as constant by putting z equals to y equals to 0 in 1. Triple integrals without limits. Do the integration according, according to taken over the volume bounded by the plane. X equals to 0, x equals to 1, y equals to 0, y equals to 1, z equals to 0, z equals to 1. Example, we can take a question. Determine triple integrals x plus y plus z dz dy dz where R is the region bounded by the plane. X equals to 0, x equals to 1, y equals to 0, y equals to 1, z equals to 0, z equals to 1. In the first step, we do it as integral x equals to 0 to x equals to 1, integral y equal to 0 to y equals to 1, and integral z equals to 0 to z equals to 1, x plus y plus z, dz dx dy. First, we can integrate this equation with respect to x. Then the equation converts to integral y equal to 0 to y equals to 1, integral z equals to 0 to z equals to 1 into x square by 2 plus xy and xz into dz by dz dy. Now the problem continues. So in this step, we apply the x limits to the equation. Integral y equal to 0 to y equals to 1. Integral z equal to 0 to z equals to 1. And we apply the x limits to the equation. 1 minus 0 whole square by 2 plus 1 minus 0 into y plus 1 minus 0 into z dz and dy. Now the step is converted to integral y equal to 0 to y equals to 1, integral z equals to 0 to z equals to 1, 1 by 2 plus y plus z into dz by dx. Now we integrate with respect to y limits. Then the equation converts to integral z equal to 0 to z equals to 1, y by 2 plus y square by 2 plus zy into dz. Then the equation converts to integral z equal to 0 to z equals to 1. Now we apply the y limits. Then the equation converts to 1 minus 0 by 2 plus 1 minus 0 whole square by 2 plus z into 1 minus 0 into dx. By the y limit. Integral z equal to 0 to z equals to 1 into 1 minus 0 by 2 plus 1 minus 0 whole square by 2 plus z into 1 minus 0 dz equals to integral z equals to 0 to z equals to 1 into 1 by 2 plus 1 by 2 plus z into dz equals to Integral z equal to 0 to z equals to 1. 2 into 1 by 2 plus z into dz. Now we do the integration with respect to z. Integral z equal to 0 to z equals to 1 into z plus 1 into dz. Now we apply the limits with respect to z equals to z square by 2 plus z equals to 1 by 2 plus 1. Finally, we get the answer is 3 by 2. Thank you.